Welcome to the Startup Competitors Podcast, where we talk with early-stage entrepreneurs and to understand what information they use to inform product roadmap, strategy, and market differentiation. Want regular updates on moves your competitors are making? You can learn more at startupcompetitors.com.
Hey there, welcome to the show. Today we're chatting with Tyler Foxworthy, who's the founder and CEO of Vertex Intelligence. You can find Tyler on LinkedIn. You can learn more about Vertex at vertexintelligence.com. You can email him at tyler@vertexintelligence.com. Tyler and I talk about data science. This is kind of in reverse order. We end on the topic of what it takes to become a data scientist, how somebody might enter the field. We talk a lot about the status of data science today, where it might be going in the future. We talk about the types of problems that data scientists like Tyler and his team might solve versus the types of deep learning opportunities that you might find more in product companies like Tesla, Google, Amazon, things like that. We open the show with kind of a quick intro for Vertex Intelligence, the type of work that they do, what makes a good project for them, to kind of set the stage and provide some context. A little bit of a wide-ranging conversation on the topic, but really enjoyed it and wanted to thank Tyler for coming on the show. Hope you enjoy it as well. You can follow the show, find Tyler on LinkedIn and say thanks for coming on and really appreciate it. Thanks for taking the time. With that, also want to do a quick shout out to Fuel Merchandise Group. Fuel is one of our newer sponsors here to the podcast. You can find them at fuelmerchandise.com. If you need any brand marketing or products for your company, you can get 10% off your first order. Just mention Startup Competitors at fuelmerchandise.com. And with that, we'll just get right on to the show. Thanks so much for listening. Welcome to the show. Today we have Tyler Foxworthy, who's the founder and CEO of Vertex Intelligence. Tyler, welcome to the show.
Great to be here. Thanks.
Why don't we start with a quick pitch for Vertex? What do you and the team do?
So Vertex Intelligence is a pure play data science and machine learning consultancy. We help companies ranging from B2B SaaS companies to enterprise companies solve their toughest data-related challenges, whether that be through data analysis, custom model development, all the way through enterprise-level cloud AI software. Custom software.
Awesome. Take that to the next level of tangibility. Give me a couple of examples of some of the work you and the team have done, because I'm guessing data science can mean a lot of different things to a lot of different people. Walk through some of your greatest hits.
I'd say over the last 3 years, we've definitely gravitated towards a handful of problems that just keep coming up over and over again in different industries. So one of them has been centered around logistics and optimization. What most people think of as scheduling is actually a deceptively hard problem when you start getting into all the constraints. So we've worked with groups ranging from schools and universities through even the Department of Defense, creating machine learning-based logistics and optimization programs to help them solve these really scalability and resource allocation challenges. Another big tranche has been around working with very large sets of data and doing data mining, natural language processing, looking for breadcrumbs and connections in large data sets. That tends to veer more towards our enterprise clients. Those are two really big areas that we've been focused on.
Awesome. Paint a picture for somebody listening, how big the company and team are today. Are you still two guys in a garage? Are you about to IPO? Like any vanity metrics you can share at all. Could be team, revenue, funding, number of clients, number of projects, anything that can help somebody understand where you're at.
Sure. So we've had 400% growth. We went from one guy in a garage to 4 guys. So right now we have 4 guys on the team full time, where we crossed the 7-figure threshold last year. Right
Congrats.
now, thank you. Yeah, it was as a bootstrap team, that was a big deal to us, and for a lot of reasons. Right now, active clients, about 5. We tend to focus on larger, bigger, harder problems. We found that it's hard to really provide the type of value that gets us excited in a super transactional way. And so we try to always go after deeper, long-term relationships where we can work on hard, interesting problems, because that's why we started the business, to always have an unending supply of interesting problems to work on.
If I'm thinking of bringing you in, do I already have a data science team and I'm leveraging you and your team to extend that capability? Or am I exploring this for the first time and you and your team are helping me figure out how to do that?
We've seen it go both ways. In general, we find that our ideal partners tend to be doing a lot of good things on the engineering and technology side of the house, but don't yet have an in-house data science team. We like to get in early enough where we can really help lay the groundwork and sort of the intellectual machinery to be able to create a scalable data science program within a company. And that tends to work best when it's sort of a greenfield.
That might be a good jumping off point just to how to think about data science in general. I suppose there's a little bit of a chicken and an egg problem with data science, right? Let's say I'm a founder and I say I'm going to go build a product right now, but I have no data because I haven't built the product yet. What should I be thinking of that would prepare me to bring your team in at some point down the road? Or what if I engaged you right now before I start writing a line of code? What are the types of questions you're going to be asking me to help me think through the long-term potential of the data that I might be creating?
So typically at that earliest stage, in that pre-data stage, it's still really important to think about where the data is going to come from and how that relates to the various business processes that you're trying to optimize. The way that we work is that we always try to look at whatever process that we're getting in the middle of and trying to affect with algorithms and recommendations and models. They have to do something, right? And so it's really important to understand to sort of put your business hat on and really think about what are the needs, what are we actually trying to solve for, and then work backwards into what is the data that we need to collect? Where are there cases where we have strongly observable information? So things that are just facts that we can collect in the data versus areas of the business or aspects of perhaps a customer journey which could be inferred but not directly observed, and use that as a framework to then go about prioritizing what pieces of information need to be collected at what point will you have enough information to start then being able to fill in the gaps with statistical inference, data science, machine learning to be able to start really providing value.
At what point in the process do you start either identifying or thinking of other third-party, external, publicly available sets of data that you can kind of layer on top of whatever proprietary data we have in our system?
That's almost always something that we want to consider almost from day one. We have a number of clients that we've worked with presently and in the past where we actually started with the open data sets and then figured what value could we provide to the business with what was publicly available. And that could come in a couple of different forms. For some clients, like we have one, I won't say the name, but they sell products into places like Home Depot and Lowe's and Menards that has a real information asymmetry in their business because those retailers don't always give the most granular information in order to be able to inform good business decisions. And so we can work with them to also help collect data from those websites via web scraping and other third-party vendors in order to give them a running start and then start adding additional methods and then blending in their first-party data with that publicly available data in order to create something that is above and beyond what their competitors would have. Third-party data, I think, should be a part of any data strategy from day one for the vast majority of businesses.
And then if you're stepping into a product that is in flight, I've got a bunch of data, but I'm not 100% sure what to do with it, but I believe that there's a way to monetize this data, and whether that's better product, better features, whatever. When you're brought in from the outside and somebody says, hey, we know there's value here, but we don't know where it is, what's the process you go through to try to tease some of that out?
So typically we'll do a 1 or 2 month exploratory engagement where we'll really get in first into the business, understand what is the business actually doing, and can we abstract those problems, those high level business problems, and sort of turn them into math problems? Can we start to develop some simple, even more mental models of what's really happening in the business, and then use that to map into what we know about what tends to work from a math and statistics standpoint against those types of problems and inside those contexts?
Do you have any, whether we make one up on the fly right now or whether you have one you can anonymize in your head, like the Home Depot example before, can you make that tangible? Do you have like a specific example of like, okay, let's say you had this business problem and we wanted to turn that into a math problem. Let's just do that. And it doesn't have to be a complicated math problem right now because we're just doing this through audio, but walk me through what that could look like. So
the first thing would be to start to look at the overall flow of information in relation to that business problem. So if you can break down that business process into its most indivisible parts. So think like a workflow, a process diagram is sort of basic things that you would do anyway just to understand what's happening in a business. Then we want to look at where is data in that process? What can be observed? What can be collected to help us understand the statistical properties of that process, almost like a machine. So at every stage in the process, there's a potential for information to be collected, for things to be observed, for things to change in a business. And so we can then dive into each of those processes and figure out, well, how would we model each of those individual components, kind of like Legos? And then when you're looking at a macro process that involves multiple independent components, how do we stack those things together? And then figure out, well, where do we have the levers? So where is there actually control inside of this business process? Because if you can't affect any of the outcomes, then you're not really going to be able to achieve anything. So a good example of that would be things like search and recommendations within software platforms. Search is great because if consumers find their way to, a particular product faster and with less friction, that tends to increase conversion rates. And then conversion rates directly improve the bottom line of the business. Then that becomes a measurable KPI for the system that you could start out with a relatively simple search or recommendation engine and then layer on more and more, sort of bells and whistles as needed in order to achieve the desired result up to sort of a theoretical max limit of performance.
Right. You're always asymptotically approaching the perfect search, right?
Right. Well, and there's a certain amount of just natural uncertainty that happens in any of those processes that you're never going to take, or you're very unlikely to move the needle from a 2% conversion rate to a 20% conversion rate based on your search. So you have to ask yourself, can I probably get to a 4% or a 5%? Maybe, maybe not. And that's where really understanding the statistical processes sort of lurking, within the business and behind the data is really important to tell you in the best probable case, is that delta, is that 50% move or 25% move going to result in enough business value to justify the investment?
Most founders start companies because they figured out a better way to solve a problem or serve a need. Not because they love tracking payroll, filling out compliance forms, and explaining employee benefits packages. And yet, all that stuff still has to be done. That's why there's FullStackPEO. FullStackPEO specializes in turnkey HR for emerging companies. Not just those core services, but advice and expertise that helps founders maximize employee potential. Curious? Find more at FullStackPEO.com.
All right, switch gears with me for a little bit. So I'm not a data science guy. I've got no idea where to start. I can go hire somebody to the team. I can bring in a consulting firm like Vertex Intelligence. I can go download a bunch of tools that say that they're going to help me do this type of thing. When I step back and say, okay, I've got a product, I've got some business processes, I want to start to get leverage out of this. When you think about the taxonomy of the market, there's different resources and places I can go. How do you think about them in the context of, as a company, you should be thinking of leveraging these things for this type of problem, these things for this type of problem? What's the right way for me to think about both getting started, but then also just from an ongoing, I need to support these models. I need to probably continue to refresh them or take a fresh look at them periodically over time. What's the right way to do that? Which I guess is a little bit of a governance question as much as a getting started question.
I'm a little biased in that I think in general, most people would be better off by seeking sound outside counsel than necessarily trying to reinvent the wheel. One of the mistakes that I've seen a lot, and it's often a point in which we are brought in to the conversation, is where a founder will sort of take this on themselves and try to learn everything about everything, or they'll reallocate a software engineer who, they took math, so they must be able to understand machine learning and statistics well enough to, move the needle on a process. But there's just so much to learn that generally trying to DIY it is not worth the effort. Data science is in general less about complexity as it is about chaining together a bunch of relatively simple ideas and just doing them exactly right. There's a refinement that happens with experience and your ability to sort of recognize the commonalities of problems across different contexts and realize that they require the same sort of underlining theoretical machinery to solve a problem. So like knowing that a business problem is actually just can be solved with basic linear regression, for instance. You could throw, neural networks at a problem. Sure, you could do that, but is that the best solution? We tend to defer to Occam's razor in most of these contexts. So I would advise, any business leader to find someone who knows what they're talking about first and save yourself a lot of time.
So just to push back on that a little bit, is there a class of problems that at this point have been commoditized enough that, yeah, pretty much anybody could pull down a chatbot package at this point, and you can probably train your chatbot to service 70% of your customer support questions? Or I'm trying to pick like the simplest problem out there. Maybe that is, maybe that isn't. But like, are there places where for these types of things, there are some great off-the-shelf tools? Maybe you can buy them, plug them in your product, and your current team is probably good enough, versus if it really is a core business process and you're trying to unlock new value, that's where you need somebody who has maybe a deeper understanding of the math behind that problem.
I think that's a really great distinction. Yeah, certainly things like chatbots, even some off-the-shelf natural language tools. I'm always a little skeptical of sentiment analysis programs and a lot of sort of the off-the-shelf NLP. But if you look at the types of tools that are built within AWS, for instance, there's some good stuff there, and there's no need to reinvent the wheel every time. So yeah, certainly there are certain use cases like that, which are going to get you good enough, but certainly not the same as having something that's tailored unique to your business.
When you look at the landscape today, what would you say if you had to come up with like a status of data science as an industry today? What would you say it is? And then where do you think it's going? So then I'm going to ask you to project out 5-10 years down the road. What's different 5 to 10 years from now from where we are today?
We're definitely seeing a bifurcation in the industry. There's sort of the machine learning, engineering, we'll call it like deep tech side of data science. And so those are going to be people working at Tesla, some of the problems that, Amazon and Google are facing. And then you have sort of we'll call it the management consulting sort of version of data science, which tends to be more BI and visualization oriented. So not necessarily super deep tech, but more about pragmatic uses of off-the-shelf tools that just help you understand your data. Not every business problem necessarily needs a custom and proprietary model to be built out. Oftentimes it's just visibility that's required. And then sometimes you layer on simple models on top of that. And so it's really, I sort of see that sort of a big split right now within sort of like two major camps.
So, and I know that this is opinion. I'm not asking you to like cite sources necessarily. If you can, that's cool, but not an expectation. If you think of like, no, these organizations get it. They do data science all the time. In fact, they've been doing it for years. They were doing it before it was called data science, versus places that are just starting to do it. The folks who haven't even really started yet, outside of the most progressive of companies. What would that landscape look like today? Where do you see we've always been doing it versus this is starting to become a thing versus there's still a ton of opportunity for disruption here?
So when I think of like outside of the FANG companies, they've been doing it well for a very long time. Take Google, for instance. Google itself is, I think, amazing because it's a company built around an algorithm. And so, the math is really in the marrow in that business. And I think you look at like Amazon and Bezos' guiding philosophy around optimization and being data driven. So those companies, I think, are phenomenal examples of doing it right and doing it for the long term. I think they're outside of that sort of obvious examples. There's other companies like, look at 8451, which was originally dunnhumby, and then was later acquired by Kroger to do all of the retail shopper, analytics and pricing optimization, promotion optimization. I don't recall off the top of my head when that company was founded, but they were doing real statistics. And back then it was just called statistics. And they've been doing that very well for a very long time. So I think, certainly in the retail CPG industry, they've had both the scale in the data that's required the use of statistics to solve very practical business optimization problems. And they've had that for a long time, and they've had the motivation to make those investments and do that right. I think where I see a lot of opportunity, where I don't yet see a lot of entrenched competition, is more in the unsexy traditional business areas, construction, real estate, SMB manufacturing, where there are a lot of companies that we talk to that are still working with spreadsheets. And even though that there have been, like manufacturing is a good example, where operations research has been a thing since World War II, right? At least what we would call operations research today. I mean, people have been using calculus to, figure out like military applications since the 1800s. But like real serious combinatorial optimization, linear programming, integer programming type things, that's been around a long time. But there's a big chasm between the off-the-shelf tools to solve those types of problems. So in practical terms for manufacturing, that's going to be inventory management, supply chain optimization, scheduling, so job shop scheduling sort of problems. There aren't a lot of great one-size-fits-all tools there. And most tools that do exist require a fair amount of customization, and that customization is really expensive. You take a platform like IBM Cplex, that's used by companies like Toyota, all the big major manufacturers to sort of dial in all of their processes and put everything under really tight control. Those types of tools really aren't super accessible for the small and medium enterprise within the manufacturing space, which is why you see so many companies still using spreadsheets to solve most of their problems. So I think that there's a big opportunity there to figure out ways to, I don't know if democratize is the right word, but there seems to be a lot of meat on the bone yet still in that area. And I would say that that's certainly true in construction, real estate development as well, from what I've seen.
If you think of the evolution of the impact that SaaS software has had on business models over time, and I'll make that tangible. So if you think of like accounting practices inside of companies, if you looked at companies some number of years ago, let's just go 10, 15 years ago, right? So everybody would have, an accounts payable process, an accounts receivable process, a bank reconciliation process. Everybody has their process for how they do a thing. But if you want company to company, they could be pretty divergent in terms of the way that they do that, the time that they do that, what role does that. I think one of the things that SaaS software has done, if you look at like a QuickBooks or a Bill.com or insert package here, it drives this incredibly consistent standard, right? You're not going to customize, at least QuickBooks Online. You're not going to customize QuickBooks Online to your accounting process. You're going to customize your accounting process to fit QuickBooks Online. And same is true to some extent with like a Bill.com and stuff like that, with the idea of like, look, this is just the way you do it today, and just get your business process to align to this software. And in a lot of cases, accounting is, one example of that, but there's all sorts of processes inside of a business where in a lot of cases, companies today are looking for the software to be opinionated around, no, this is the way you do it. And it's built into the software. And they're not necessarily looking to, be able to customize the software with their own workflow. This is obviously not true at the enterprise level. A Fortune 100 company is a special snowflake. They do their own stuff. But if you look at the vast majority of SMBs, like they're looking for somebody to come in with an opinion and say, this is how you do it. Just take the software and run, and it's going to work 90-ish% of the time. So that's happened over some period of time, call it 20 years, right? In the last 20 years, as SaaS has slowly been chewing up the world, you see more and more commodity business processes just move to like a Monday.com and, whatever, or Workday. Monday is a different thing. Yeah. If I fast forward 20 years on these types of problems in the data science world, am I going to see the same thing? Am I going to see kind of pluggable components that I can just kind of pull off the shelf? And it's not perfect. It's never going to be completely customized. It's kind of what we were talking about earlier about chatbots, right? Like it's not perfect. It's not going to be completely customized to your system, but like, 90-ish% of it'll get you there, right? It'll get you good enough that you could start doing this. And then if it is your competitive advantage, if it is your edge to need this to go the next 10%, which it might be, then you're going to bring in the big guns. But if it's not, if you just need to be good enough at this, then this is probably fine. When will we start to see that kind of development in the data science space the same way that we see it in the kind of the custom software development space has seen that, right? Where 10 years ago, you would have hired a firm like a Developer Town to come in and build you custom software to help you in your accounting team. Today, you would never do that, right? You're just going to pull something off the shelf and go.
I think to answer that question, you have to sort of get into what are the challenges that make it hard to have reproducible data analytics processes in the first place. One of the challenges that we see repeatedly that is a barrier to replication is data quality. The extent that poor data quality results in sort of special workout sort of situations where you have to, make either compromises, tweak models, and do custom stuff in order to sort of make the models work with the real world. That's always been a challenge that we've seen. So I think a lot of it will really depend on the extent to which businesses use other processes that kick off lots of good, clean data. Because math and stats is always going to be a crap in, crap out sort of environment where, take for instance, the work that we're doing in the retail space, where we're looking at things like price elasticity, pricing and promotion optimizations. The math behind that is actually relatively straightforward. What's not straightforward is all the hedging you have to do for the data quality issues.
Can you give me some example of data quality issues there?
Lack of continuity, measurement errors, breaks in the data where the models don't necessarily accommodate those sort of breaks from their assumptions. So if you're trying to fit a price elasticity model, there are a lot of assumptions that go into that about the distribution of demand, supply and demand, and we don't expect there to be big jumps in demand or 3-week gaps in collected data. Those sorts of issues sort of make you have to really work really hard to make sure that the answers, that when you fit those models to the data, that the answers make sense and that they're right and that they're defensible. So you just have to be much more, I guess, defensible is the best word. When you're dealing with real world data, you have to be on the defensive for all the things that can make that real world data be in conflict with the sort of fundamental assumptions for the models that you're trying to apply. So going back to your previous question about when do we get to a more plug and play components, I would say if data in general was in better shape, we could be there now for what much broader subset of the types of problems, at least that we see in our business, because then we wouldn't lose sleep over all the things that can go wrong with a model because there's a problem in the data itself. I think that's one of the big departures from like traditional software engineering too, is that when you're writing code, you can write unit tests for a lot of deterministic behaviors. So customer press this button, or they type this input into a field, or we look for, data flows. You can control a lot in traditional software. When we get into machine learning or statistics in general, a lot of the things that can go wrong have nothing to do with the math itself. It's everything to do with the inputs. And so you have to really hedge against all the things that can go wrong and violate your distributional assumptions about your inputs in order to trust the models. Because the models are almost like sort of these platonic ideals. We know from first principles that the models work. In a perfect world, let's say going back to like the pricing discussion, we've got 100 years of microeconomic theory which backs up why these types of models should work. It's just reality that gets in the way, right? And so we spend so much more of our time thinking about the asymptotics of the data itself. So where do the extreme values come in? Are there hidden trends? Are there hidden gotchas in the data that then violate sort of the foundational assumptions of these almost platonic models that would be applied? Solve that. I think the Lego style components will come, but it all boils back down to data. Hopefully, though, like you said, if the more companies begin to integrate with SaaS products which templatize their workflows, right, and we start to see more uniformity in the data, more consistency. It's one of the reasons we love working with SaaS companies, because they tend to collect good structured data, whereas you work with let's say a plumbing business or an electrical contractor. There's some really cool business problems that we've worked on, and they're a lot of fun, but there's a much bigger hill to climb just to get to useful data to then apply those models.
In the interest of time, I got to get you out of here. Switch gears with me again one more time. If I want to get started in data science, because I think this could be a good career path to follow, and I'm just coming out of high school, what do I do? What's the path that is going to take me down the road to where I'm going to be able to do kind of some of that management consulting level analysis and get to work on the really tough problems?
We see a lot of different paths that people have taken, but I think in general, the most consistent path to success that I've seen, and it mirrors my own path, is study some STEM discipline and get really deep into it in your undergrad. So whether that be, math, computer science, engineering, even physical sciences, physics, analytical chemistry, electrical engineering, all of those I think are great paths to learning to apply the tools of mathematics to the interpretation of data to solve practical problems. So I think getting some fundamental training in that and knowing the basics, understanding soup to nuts, how to work with linear algebra, how to do hypothesis testing, basic machine learning, just knowing the basics, but knowing them really, really well, I think is the best place to start. In general, most businesses don't really need deep learning, for instance. We hear a lot about deep learning, in the press, and there's some really awesome, super impressive use cases there, but that's really the exception, not the norm. I would rather, and certainly when we're hiring and having conversations with earlier career or aspiring data scientists, I look much more towards someone who knows what they, even if it's simple. So you take linear regression or, Bayesian analysis. If they know that well and they can explain how they come to conclusions about a problem, if they can show that they know how to structure a problem and sort of know how to do that mapping from the business process to the math problem, that's far more important than knowing every single trick in the book, at least to start. I go back to, and I say this all the time, that most of this field is doing relatively simple things. So following even what I call classical machine learning. So everything that's not deep learning, knowing those techniques inside and out and knowing when to apply them is far more important than, adding lots of, complexity, at least in terms of being able to really come up with useful solutions that can affect business outcomes.
What are likely first jobs for somebody who's thinking about going into data science?
It's getting harder and harder for people's first job to have that, the data science title. Years ago, certainly when I was getting started, there was sort of a mad rush to hire data scientists. And so we saw a much broader swath of experience coming into the field. Nowadays, it's getting much more consolidated, much more competitive. And so looking for jobs where you can be involved in business processes and be working in data, even if you're not necessarily a data scientist, are going to be good paths. So that could be a business analyst. That could also be a software engineer. Anything that's sort of adjacent to it wouldn't be a bad place to start.
All right. I want to do one more jump. So you run a data science consulting company. Help me solve this problem. There's a pattern that I've seen. This is an anecdotal pattern. I have no data necessarily to back this up other than experiences we've had here with some of our companies. Our experience has been it's very difficult to hire a good digital marketing firm. Anecdotally, it would seem if a digital marketing firm is really good at selling products, if they're really good at converting customers in customer acquisition, they very quickly recognize that they're very good at this. And instead of making a bunch of money for other people, they come in and they say, well, we should just sell our own products since we're clearly good at this. And then they shut down the digital marketing firm and they start marketing their own products and they just go grow a business. And there's plenty of examples in the wild where you can see that on the digital marketing side, right? Like, oh, look, they're really actually good at this. They've solved it, right? And now they're going to go do it themselves, which makes it very difficult to go hire a good digital marketing firm. That's why there's a lot of people out there who can help you spend more money, but not necessarily get more customers. And data science consulting feels like it could suffer from that same problem where if you're really good and your team is really good at solving these types of problems, and you can dramatically move the needle for your clients in terms of outcomes, at some point, as a consulting firm, you're going to look at that and you're going to say, well, why do we keep doing this for them? Why aren't we doing this for us? We should go solve our own problems and make all that money that we're making for our clients. So is that observation real? How do you manage that? When you think about growing and scaling a data science company, what does that look like?
That's been a question that's been at the top of my mind for the better part of a decade. It really has. I look at what we do at Vertex not through the lens of, hey, we're going to scale this company to 100 data scientists and we're just going to do consulting. I see it much more as a way to collect good problems, which could beget good businesses. You take the work that we've done in scheduling and optimization. Those aren't one-offs. That is a part of a broader program to build out that intellectual property and the software behind all of that and wind it up and spin it off. So I think for us, I think your observation's really correct. But we see the consulting side of it as a great way to sort of identify common threads, problems that people keep asking us over and over again, and figuring out, hey, well, is there a way that we can generalize this? Can we create 80% of the value, for instance, and bottle it? Or maybe there's a services component to it, but that's still pretty damn good margin if you can automate the worst, most mechanical parts of a process. So
starting to create the Legos.
So you start to create the Legos, and even if they're not perfect, those still are a tool to create margin. And so ultimately, I think we keep going. We keep finding good problems. But for us, the long game is not to keep consulting forever, to grow a massive consulting firm, but it's more about problem discovery and spinning these things off into independent entities where they can really take these things even deeper and take them to market and scale them.
I like it. If I looked at your calendar or your nightstand on a weekend, what would be the activities, books, podcasts you would be diving into to get smarter right now? You hit me with like a top 2 or 3 of the last 3 months of pieces of content that you're really into?
Yeah. So a lot of books. I love reading. I would say over the last 6 months, Poor Charlie's Almanac's been a favorite. I don't know if you're familiar with that.
I'm very familiar with
Charlie
that.
Munger. Yeah, it's the wit and wisdom of Charlie Munger, whom both Warren Buffett and Charlie Munger have been great teachers for me and a lot of other people I know in the business community. Just thinking about how to do things right, how to maintain, a high degree of principles in your operations and business, and how to play the long game. So I find a lot of great inspiration by learning from great investors. Along those lines, Never Split the Difference, Chris Voss on negotiation. That's been a good recent one.
He also, that is a fantastic book. I read that book. I believe he was also interviewed either by Rogan or Ferris. It was like a 4-hour interview, so it was one of those two, and it was fantastic. So also worth going out and finding that piece of audio as well.
Howard Marks, Mastering the Market Cycle, much more investment-oriented book, but I think it shows to me great ways to think about how we can observe information from the world and sort of synthesize that into making good decisions as investors. So understanding that we can't predict the future outside of some very limited context. And so reminding ourselves that trying to predict the future shouldn't be the goal. Trying to understand the present in the context of history and knowing what are the best decisions I can make in this moment right now with what is observable and filtering through past observations. That, to me, is a really powerful mental model for how to approach the application of data science in business as well. It tells us to not get too over our skis and trying to get outside of our circle of competence and what these algorithms can really do, but instead focusing on what's the most practical, useful thing that I can do with what I know with a high degree of confidence.
Right on. Thank you. Thanks for sharing those. Folks want to find you online. If they want to get in touch with you, what is the best way for them to do that?
Either shoot me an email to tyler@vertexintelligence.com or check out our website, vertexintelligence.com.
Right on. Tyler, thank you so much.
Yeah, thank you.
Startup Competitors provides monthly handcrafted email updates on your top competitors. Keep up to date on new hires, marketing activities, events, awards, new product launches, pricing changes, funding, and a bunch more. Learn more at startupcompetitors.com.